Hello everybody. So we'll be studying trigonometry today. And trigonometry, we see around two questions in every exam. In every exam, we usually see two questions coming in, and one of them is usually simple, and the second one is a little tough at times. Okay, the second question is a little tough at times. So we have multiple things in trigonometry, particularly if you have a solid background of ratios, plus you know angle values, then you will definitely crack that one question. Okay, but if you know the level formulas, if you know the advanced level formulas, then you'll be able to crack the second question. So this is pretty much about it. If you're able to understand, let's say, only the 50% of the trigonometry, I'm pretty sure you'll be able to crack definitely one out of the two. And you need to have a solid foundation of the first portion so as to reach the second portion. Okay, so I'll be removing all of this, whatever I've written here. I'll be removing all of that, and um, let's really talk about what trigonometry is. Trigonometry is the study of relations between the sides and the angles of a triangle. So what usually happens is trigonometry can be applied to all sorts of triangles, but the main motive or the main area where it can be used is a right angle triangle. Okay, main area where it can be used is a right angle triangle. Let's assume this is a sine. These are three angles over here. We know very well that the sum of all the three angles of a triangle are 180 degrees. The sum is 180 degrees. So if this one is 90, the other two would add up to 90 as well. So we have two angles over here. We can call this one angle A. For simplicity, this is angle A. Or if you need to have a complete name to this angle, it is angle BAC. Similarly, if you need to have a complete name for angle C, it is BCA. Okay. So we need not use the annotation multiple times. That is why we give names to angles. And the names that we usually give are Greek in nature. Okay? The the names that we give are Greek in nature. They can be alpha, beta, gamma, phi, or epsilon, or no, this is delta. Okay? Alpha, beta, gamma, delta. These are good enough. If still something else comes up, need not worry about it. The most standard name that we would be continuously and multiple times using for any angle is going to be theta. Okay, for the ones who don't even understand what theta is nothing but a name for an angle. Never get confused. This is the most standard annotation we are talking about, and theta is the name of an angle. That's it. Got it? Let's move forward. Trigonometry means the three sides and measurements of it. Once we have a theta with us, we have to apply ratios to it. We have to apply ratios to it. Whenever we have an angle, we have a standard set of 6 ratios. We have a standard set of 6 ratios, out of which you must have heard sine, cos, tan, cot, sec, and cosec. So these are the 6 ratios. Sine is the opposite of cosec, cos is the opposite of sec, and tan is the opposite of cot. A better way of saying it would be cosec is the opposite of sine, sec is the opposite of cos, and cot is the opposite of tan. Got it? So these are the opposites that I'm talking about. Opposites means they are simply reciprocal of each other. Nothing more than that. Okay? So usually we study them in the terms of acute angles, and these are called the trigonometry ratios. Let there be a triangle ABC, which we have already talked about. There is something called the hypotenuse, which is the longest side of a right angle triangle. Then there is something called a perpendicular, the one along which the triangle stands is a perpendicular, and the side along with which a triangle rests is called the base. So I have height, perpendicular, and base. These ratios have very standard and very fixed values. Okay, these ratios have very standard and fixed values. When I talk about sine, okay, this is written as sin, sine, or sin in a way, but we call it sine because its full form is sine, SINE. Okay, so sine theta. This means I am applying the ratio of sine to the angle theta. I am applying the ratio of sine to the angle theta. This is the theta line, theta angle which we are talking about, which is angle C, right? Which is angle C. So sine theta is nothing but opposite upon hypotenuse or perpendicular upon hypotenuse. Okay, let me redraw the same right angle triangle over here. And we are talking about this angle theta. This angle theta. This is opposite of theta. This is adjacent of theta. This is opposite of theta. This is adjacent of theta. And this is the hypotenuse for theta. So for particularly for theta, we have sine theta. Sine theta, I'll give you a very quick mnemonic for it. Okay. The quick mnemonic stands at so, ka, CAH, ka, and toa, TOA. So, ka, toa. You need to remember only these three. All right. You need to remember only these three. Sine stands for opposite upon hypotenuse. Cos stands for adjacent upon hypotenuse, and tan stands for opposite upon adjacent. Okay, so for this particular manner, what I'll be doing is I'll be using sine theta. Sine theta here means opposite upon hypotenuse. The opposite side is AB and the hypotenuse stands at AC. So sine theta is equal to AB upon AC. Talking about cos theta, as I have already given, adjacent upon hypotenuse. So cos theta is equal to adjacent upon hypotenuse. For the angle theta, adjacent stands at BC upon hypotenuse. Hypotenuse stands at AC. So cos theta is equal to BC upon AC. Talking about tan theta is opposite upon adjacent. Opposite means AB and adjacent means BC. So AB over BC. Tan theta was one of those trigonometric ratios which was used a lot throughout all the chapters, throughout the chapter of heights and distances particularly. But here we'll be having a mixture of all these. We'll have a mixture of all these ratios coming in our questions. Okay, so we've done sine, we've done cos, we've done tan. As I've already said, that the opposite of sine would be cosec theta. The opposite means the reverse, or reverse in the sense the reciprocal. The reciprocal of cosec theta or the reciprocal of sine theta, which is AB upon AC. If I write it as AC upon AB, I would get cosec theta in my equation. Similarly, I have sine, cos, tan. I have cosec. Let me talk about sec. Sec theta is the opposite of cos. So it would be AC upon BC. Talking about cot theta would be equal to the opposite of tan theta or the reciprocal of tan theta, which is equal to BC upon AB. So the main focus, your main focus should be sitting only at sine, cos, and tan. If you know that cosec, sec, and cot can be derived. Okay, so that is why you can remember it with the help of so, ka, toa, SOH, CAH, TOA, TOA. Okay, it's so, ka, toa. Got it? Got it. So I have given you the main foundation points of trigonometry. Theta is nothing but the name of an angle. Theta would take up values in the subsequent lectures as well. Okay, theta would be given a few values in the subsequent lectures, but for now, theta is nothing but the name of an angle. Sine, cos, tan, cosec, sec, cot. These are ratios. All right, these are ratios which we'll be studying. Moving forward, this is the same thing which I have taught. Sine is BC upon AC, cos is AB upon AC, tan is BC upon AB. Let me check BC upon AB. No, they've used a different one. See, whatever I've taught is definitely valid. it is definitely valid. The only point is that is called sine is called p upon b. Okay, sine is called p upon h, cos is called b upon h, tan is called p upon b. Here cosec is called h upon p, sec is called h upon b, and cot is called b upon p. So after seeing all this, the simple ratio so ka toa stands valid. Okay, the so ka toa stands valid. If you wish to learn it this way, the one which is written over here, it's okay. But I think this would be the easiest way to learn things. Got it? Let's move forward. As I've already said, the reciprocal of cosec is sine, the reciprocal of sec is cos, and the reciprocal of cot is tan. Okay, this is how things go. Also, there is a ratio which is very unique in nature, which is called the tan ratio or the tangent ratio. Tan theta is also equal to sine theta upon cos theta. Sine theta stands for opposite upon hypotenuse. Similarly, cos theta stands at adjacent upon hypotenuse. If I divide both of them, I would have opposite upon hypotenuse divided by adjacent upon hypotenuse. If I will have to use a reciprocal, and these two would get cancelled out. So the value of tan theta would be given as opposite upon adjacent. Okay. So sine, cos, and tan are the only three things that you need to learn. Cot is also equal to cos upon sine. Cot is also equal to cos upon sine, and we need not worry about it because we already know that tan is equal to sine upon cos, and cot is the reciprocal of tan. So cot is equal to cos upon sine. Trigonometric ratios of acute angles, these things are not very important, but there is a very standard theorem which you must have used at multiple occasions, which is the Pythagoras theorem. The Pythagoras stands at hypotenuse square is equal to the base square plus height square, or hypotenuse square is equal to the base square plus perpendicular square. Right? Opposite square plus adjacent square is equal to hypotenuse square. Right? Then there are a few triplets which are, let's say, 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, etc. So these are the triplets that whenever you see 24 and 25, you would know that the third side is definitely 7 if we are dealing with a right angle triangle. Similarly, whenever you see 8 and 17, you would know that the third side is 15 because we would be dealing with right angled triangles. So in such a situation, it is very handy and very necessary for you to remember and learn all the triplets. When I say all the triplets, I believe around 10 to 15 triplets are the very common ones. And if you remember them, then you'll be able to track things and you'll be able to sail through very easily. Right? Let's move forward. As I told you, that theta is nothing but a name of an angle. The angle can also get values. The angle can also get values. We would be restricting ourselves for 0 to 90 degrees at the moment. Okay, we'll be restricting ourselves to from 0 to 90 degree at the moment. If somebody would ask me what is the value of sine 120, then there is definitely a way forward that sine 90 plus 30 can be done, and there is a formula involved as well. Okay, so for now you must learn the first three ratios and all of their angle values. Okay, sine is going on increasing and increasing over here. So sine 0 is 0. You have to remember this. The opposite of sine 0 is equal to cos 90. So both of them would be 0 here. Cos 1 and we have sine 90. They would be equal. Similarly, sine 30 would be equal to cos 60 and cos 30 would be equal to sine 60. And there is one juncture or there is one moment when sine and cos both would get the same value, and that is at 45 degrees. So at 45 degrees, both sine and cos would have the same value, which is equal to 1 upon root 2, right? Which is equal to 1 upon root 2. Talking about tan, talking about tan, I have tan 0, which is 0 degrees, which is 0 in numerical value. I have tan 30, which is 1 upon root 3. I have tan 45, which is 1. This is very, very regularly used. Tan 45 being equal to 1, you have to memorize it. Okay, you have to rote learn it. That the value of tan 45 is equal to 1. Then talking about tan 60 is equal to root 3. And talking about tan 90, the value of tan 90 is nothing but infinity. Okay, the value of tan 90 is nothing but infinity. Need not remember the values for cosec, sec, and cot. Okay, I would not recommend learning these values. Got it? Got it? We have understood all the ratio values at different angles. There are very definite values at each angle, but the ones which are most important and required for the examination are at 0 degrees, 30 degrees, 40 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so these are the ones which are most important in nature. So now there are angles which complement each other or which complete each other, and they have equal values of each specific ratio. We declared that the value of sine 60 degrees is equal to that of cos 30 degrees. Similarly, the value of cos 30 degrees, or sorry, the value of cos 60 degree is equal to that of sine 30 degrees. So there is a very peculiar pattern that is being followed. Also, the value of sine 0 degree is equal to cos 90, and the value of sine 90 degrees is equal to cos 0 degrees. So the peculiar pattern that we are able to see here is that when angle A plus angle B, angle A means the angle in this equation, the angle attached with sine, that is 60 degrees, and angle B is the angle attached with cos, which is 30 degrees. So angle A plus angle B is equal to 90 degrees. Whenever the sum of the angles are 90 degrees, at that point, the ratios are exchangeable. Okay, the ratios are exchangeable, which also means that they are complementary with each other. Okay, the ratios are complementary with each other. So the value of sine theta is equal to cos 90 minus theta. The value of cos theta is equal to sine 90 minus theta. Similarly, for tan theta, it is going to be equal to cot 90 minus theta, or cot theta is equal to tan 90 minus theta. Further, the value of sec theta is equal to cosec 90 minus theta, or the value of cosec theta is equal to sec 90 minus theta. Good enough? Okay, now we'll be moving to another concept. There is another concept of having, so we have four different quadrants. These are the same quadrants which we've learned about in coordinate geometry. Okay, these are the four quadrants. This is nothing but a small plane where we have an origin which is 0, 0. When we calculate the length or the degrees of any angle or the measurement of any angle, it is always done in the anti-clockwise direction. Okay, it is always done in the anti-clockwise direction. So from 0 till this point here, it is a 90 degree. Here it is 90. We've already written it. It's here. Then there is 180 on the other side. Then there is 270 on the side which is below. And then there is 360 which is superimposing on the 90. But we are looking at it from the other side. Okay. So in the first quadrant, all ratios are positive. All ratios are positive in nature. Further, the value of sine is positive in the second quadrant. In the third quadrant, the value of tan is positive. In the fourth quadrant, the value of cos are positive. So when I say I have to remember this, I have the first, I have the second, I have the word first, I have the second, I have the third, and I have the fourth. So in the first quadrant, the value is all. Okay, all are positive. So I would give it a mnemonic of after. After. In the second, only sign is positive. I would give it a mnemonic that is school. After, in the third quadrant, tan is positive. At that time, I would give it the mnemonic 2. And in the fourth quadrant, cos is positive, which I would give the mnemonic as college. So after school to college, right? After school to college. This is the mnemonic that we really want to talk about. Okay. So after school to college. In this way, we are able to understand in the first quadrant, second quadrant, third quadrant, what all values are going to be positive. In the first one, all. In the second one, sine. In the third one, tan. And in the fourth one, cot. So this is how you remember what all values are going to be positive. Got it? Got it. Now, the ratios, they change at 90 degrees and 270 degrees. If somebody asks me what is the value of sine 90, I can say this value is equal to cos 0 degrees. If somebody asks me what is cos 0 degrees, I can say that this is sine 90 degrees. If somebody asks me what is tan 90 degrees, I can say that this is equal to cot 90 degree. Okay, that is when the ratios change. Same goes out for the value of 270 degrees, right? Let's move forward. Now, ratios, ratios, ratios remain same at 180 or 360 degrees, or which is also called at 0 degrees. The ratios remain the same, and one complete revolution is equal to there being 0 degree as well and 360 degree as well. Also, there is a very important output which is pi. Okay, pi is equal to 180 degrees. Okay, 180 degrees. Pi is equal to 180 degrees. So pi by 2 is 90, 3 pi by 2 is 270. So we can also say that 2n pi is equal to 360 degrees. The most important thing that you can easily remember is that the value of pi is equal to 180 degrees when we calculate it in a graphical notation. Okay, when we say 2 pi r, that means this is the circumference. We say that this is the circumference of a circle. This is the circumference of a circle. In this particular circumference of a circle, 2 pi is basically a circle, so it completes one entire revolution. That is when the circumference is created. So that is why that is where we create or pick up 2 pi from. So the value of pi is 180, the value of 2 pi is 360. That is how a circle is created. This 2 pi is equal to 360 degrees. All right. Now, sine minus theta. If we go to this coordinate plane, we saw that every angle starts from here in the first quadrant. If some angle has been written as a negative angle, so it would start at a plane which is opposite to it. That means this sine minus theta is in the fourth quadrant. Sine minus theta is in the fourth quadrant. In the fourth quadrant, only cos is positive. In the fourth quadrant, only cos is positive. So sine minus theta is equal to minus sine theta. Sine minus theta is equal to minus sine theta because of the fourth quadrant effect. Similarly, cosec is nothing but the opposite of sine. So cosec minus theta is equal to minus cosec theta. Similarly, tan minus theta is equal to minus tan theta. Why? Because in the fourth quadrant, tan is not positive. Okay, so that is why tan minus theta is equal to minus tan theta. Further, cot minus theta is equal to minus cot theta. Okay, cot minus theta is equal to minus cot theta. where cos minus theta is equal to cos theta. Why is this true? Why was each and every other thing getting a sign of minus and we were not getting a sign of minus? There was a reason behind it, because we were talking about the fourth quadrant. Okay, we were talking about the fourth quadrant. Here, when I say cos minus theta, we get it as equal to positive of cos theta, because in the fourth quadrant, the value of cos is positive. Okay, positive in fourth fourth quadrant. It is positive in fourth quadrant. And sec minus theta, it is nothing but the opposite of cos. So it will follow the same principles as that of cos. Right? Let's move forward. Now, now we are quickly coming down to the questions, and I would expect you to solve them as easily and as quickly as possible. I've been given the value of cot theta as 7 upon 8. I'm quickly assuming a triangle. I'm quickly assuming a triangle and calling it theta here. Cot theta is 7 upon 8, which would become 7 upon 8 like this, because tan theta is opposite upon adjacent. So cot theta would be adjacent upon opposite. This becomes 7 by 8. Now it is asking me the value of 1 plus sine theta multiplied by 1 minus sine theta whole divided by 1 plus cos theta into 1 minus cos theta. I can see a plus b multiplied by a minus b in the numerator and c plus d into c minus d also in the denominator. So this brings me to the point where I can say that this is a square minus b square upon c square minus d square, which is equal to 1 minus sine square theta upon 1 minus cos square theta, 1 minus sine square theta whole upon 1 minus cos square theta. 1 minus sine square theta stands for cos square theta, and 1 minus cos square theta is nothing but sine square theta. I know I have overstepped it, but I want you to learn this method as well. We say that cos upon sine, we say that cos theta upon sine theta is equal to cot theta, and there is a square as well which was missing. So this is nothing but cot square theta. We have the value of cot theta as 7 upon 8. So we can say the value of cot square theta is nothing but 49 over 64. This is when I I played with 1 plus sine theta and 1 minus sine theta. I brought in algebra over here. I used the basic identities of sine square theta plus cos square theta being equal to 1. This is the identity which I haven't talked about. Okay, this is the identity which I haven't talked about. I will be teaching the same identity right here. Whenever we talk about sine square theta plus cos square theta, the value of this is always equal to 1. No matter what the value theta can take, sine square theta plus cos square theta shall remain equal to 1 universally. Okay, it is universally true. Further, talking about sec square theta is equal to 1 plus tan square theta. Further, talking about cosec square theta is equal to 1 plus cot square theta. Cosec square theta is equal to 1 plus cot square theta. So these are the three identities which you must know. And these were the ones which I used here. There was another alternate method. There was another alternate method which we could have used. We knew the value of cot. Through this triangle, we could have known the value of sine as well. We could have known the value of cos as well. If I try to find out the value of sine from here, I would firstly have to calculate the value of the hypotenuse. The value of hypotenuse would have been equal to 8 square plus 7 square. which is 64 plus 49, and this would have become 113. So root 113 would have been the value of the hypotenuse. Now I could find out the value of sine theta from here, which is equal to 8 upon root 113. Also that of cos theta, which is 7 upon root 113. 7 upon root 113. 1 minus sine square theta whole upon 1 minus sine square theta whole upon 1 minus cos square theta. You could have applied these values in the question directly, and you would have achieved the same answer. But the response which I have taught you through this question is universally applicable, and also this is very mathematically correct. So please follow my method, need not follow the other method. It is just for the ones who are finding it difficult to solve the algebraic equation that we have created. Right? Let's move on. Now, tan A has been given as 5 by 12. I need to find out the value of cos A. Tan A has been given as 5 by 12. This is A, B, and C. I need to find the value of cos A. In this triangle, tan A means 5 upon 12, opposite upon adjacent. What about cos A? Cos A stands for adjacent upon hypotenuse. AB upon AC. The value of AB is 12. The value of AC square is equal to AB square plus BC square. AC square is something we have to find out. AB square is 144 and BC square is 25. So 144 plus 25 would give me a 169, and the value of AC square is equal to 169. Also, the value of AC from here would come out to be 13 units. So AC is 13 and AC is 13 here, and I can easily say that the value of cos A is 12 over 13. This is my answer. Right? Understood? Okay, let's move on. Cot A is 5 by 12. Cot A is 5 by 12. I'll assume A here, B here, and C. Same way, 5 by 12. Cot is the opposite of tan. Tan means opposite upon adjacent. So we'll talk about 5 by 12 like this. If this is 12, this is 5. 12 square is 144 plus 5 square is 25. This is going to be 169. And the value of AC again comes out as 13. This is something we have found out. So the value of the following expression, 5 by 6 being multiplied by 1 minus cos square A whole upon 1 minus sine square A. 1 minus cos square A upon 1 minus sine square A. There is a difficult way of doing it and there is a smart way of doing it. I will help you do both of them. First, following the smart way. The smart way says that 5 by 6 is 1 minus cos square theta, which is equal to sine square theta, whole upon 1 minus sine square theta, which is cos square theta. So sine square A whole upon cos square A. This would give me 5 by 6 tan square A. This would give me 5 by 6 tan square A. Similarly, this would give me 5 by 6 being multiplied by, this is the difficult way, okay? This is the regular way which I am solving. Let me complete this first. I have the value of cot A with me. The value of tan A would be equal to the opposite of cot A, opposite or the reversal of cot A, reciprocal of cot A, which is going to be 12 upon 5, right? I'll employ the value, or I'll put in the value of tan A here. 5 by 6 multiplied by 12 by 5 multiplied by 12 by 5. 6 2s are 5 and 5 are gone. We get the final result as 24 over 5. We'll get the final result as 24 over 5. Got it? Now let me go with the regular formula. 1 minus cos square theta, cos square A. Cos is adjacent upon hypotenuse, 5 upon 13, which I can also write as 25 upon 169 whole upon 1 minus sine theta, opposite upon hypotenuse, which I can write 144 upon 169. The 169 would get cancelled out. This would give me a 5 by 6 multiplied by 169 would get cancelled out. So 169 minus 25 would become 144 whole upon 169 minus 144 is equal to 25. Solving it now, this would become 5 5s are 25. Solving this here, 6 2s are 12 and 6 4s are 24. I get the same response of 24 upon 5. I get the same response of 24 upon 5. I want all of you to analyze both the approaches and then follow the smart approach only. So after understanding how to find out all the different ratios, we'll be moving forward to a different range of questions. Okay. So here I can see that cos theta minus sine theta is equal to root 3 cos 90 minus theta. And I need to find out the value of tan theta minus cot theta. So for this particular question, what I would do is I would first of all rewrite this thing. Cos theta minus sine theta is equal to root 3 cos 90 minus theta. I've already learned that at 90 the trigonometric ratio changes. It changes to its own complement. That means cos 90 minus theta is nothing but sine theta. So here cos theta minus sine theta is equal to root 3 sine theta, right? So if I have root 3 sine theta, I'll bring this sine theta to the other side and I would write that cos theta is equal to root 3 sine theta plus sine theta. I'll take sine theta common from here and I would get a root 3 plus 1 multiplied by sine theta being equal to cos theta. If I bring this sine theta down here, then I would get cos theta upon sine theta being equal to root 3 plus 1. Cos upon sine is nothing but cot. So the value of cot theta is equal to root 3 plus 1. The question says you need to find out the value of tan theta minus cot theta. If I have the value of cot theta being equal to root 3 plus 1, I can find out the value of tan theta by reciprocaling it. Reciprocal of that would be equal to 1 upon root 3 plus 1. So now what do I need to do? I need to subtract cot theta from tan theta, which would be equal to 1 upon root 3 plus 1 minus 1 upon minus not 1 upon minus root 3 plus 1, which is nothing but cot theta. So what should I do now? I need to solve this in order to achieve the right answer. When I do that, I get what could be done. I think it will be better if I rationalize the denominator in the first equation and then simply add it to the other one, or simply subtract from the other one. This entire thing would be in a bracket. So for rationalizing the denominator, I would have to multiply it with its conjugate pair. The conjugate pair is root 3 plus 1 and root 3 minus 1. So root 3 minus 1, when it is multiplied, so it is going to be 3 minus 1, which is 2. So a 2 would come here and root 3 minus 1 would pop up here. Root 3 minus 1 would pop up there and we have a conjugate pair like this. Minus root 3 minus 1. So this is what we've achieved from it. So now I can say that this is root 3 by 2 minus root 3 and minus 1 by 2 minus 1. This minus 1 by 2 and minus 1 would make for minus 3 by 2, and root 3 by 2 minus root 3 would go for minus root 3 by 2. So this is the final answer that we're expecting out of it. Okay, minus root 3 by 2 minus 3 by 2. Got it? I've done nothing, I've just rearranged the terms. Most of the answer was visible here itself, right? Most of the answer was available or visible here itself. I have done a lot of moving up and down. Okay, a little bit of value putting up, not value putting, a little bit of moving the square root around. So that's what I have done. Moving forward now, if tan 90 minus theta is equal to 2 by root 3, then the value of 2 root 3 tan theta minus 1 is what? I have tan 90 minus theta as something which is 2 over root 3. Tan 90 minus theta would shift itself to cot theta. It would be equal to cot theta. That would be 2 over root 3. Similarly, the value of tan theta would be equal to root 3 by 2. Now the question is, find out the value of 2 root 3 multiplied by tan theta plus 1. Here I have tan theta as root 3 by 2. So 2 root 3 multiplied by root 3 by 2 plus 1. The 2 would get cancelled. Root 3 and root 3 would become 3. And 3 plus 1 is equal to 4. So 4 is the answer that I'm looking for. Good enough? Let's move forward. Now, talking about trigonometric functions, I have already talked about after school to college. I've already talked about after school to college. From here, I'll try to find out in which quadrant this angle is lying. I'm saying sine minus 8 pi by 3. Sine minus 8 pi by 3. We already know that the value of pi is equal to 180 degrees. So when I multiply it by 8 and 180 degrees whole upon 3, I get the value 3 6 are 18 and 8 6 are 48. So essentially what I'm looking for is sine minus 480 degrees. The entire quadrant starts from 0 degrees and ends here itself at 360 degrees. So once it's ending at 360 degrees, I can say that sine is at minus 360 degrees and minus another 120 degrees, right? So it is lying somewhere here at minus 120 degrees. So minus 360 would not have any effect on it because it is coming back to the same 0. So this question essentially has boiled down to sine minus 120 degrees. Now, if I'm talking about minus 120 degrees, this was the wrong side which I took it to. It should have gone in the opposite direction. Okay, it should have gone here. I'll tell you what mistake I committed here. I won't erase it away because there might be people who would learn from it. If I'm going in this direction, this is the anti-clockwise direction. These angles are positive in nature, but I'm supposed to go in a negative direction because the angle is negative in nature. So as soon as I reach from here till here, I'm going in the wrong direction, which means I'm entertaining a negative degree. I'm entertaining a negative angle, which is minus 90 degrees. And when I surpass this point and reach somewhere here, I am entertaining a minus 120 degree angle. So slowly I can mark this down, and here at minus 120 degrees, sine theta has been asked for. So which quadrant is this? This is the first one, this being the second one, this is the third one, and this is the fourth one. So after school 2, in the third quadrant, only tan is positive, but we are talking about sine theta here. That means sine minus theta would become minus sine 120 degrees, would become sine 120 degrees minus sine 120 degrees, right? So we have sine minus 120 degrees or minus sine 120 degrees here. I will have to convert it to minus sine 180 degrees minus 60 degrees. it was already said that at 90 degree or at 270 degrees, you would achieve a point. At 90 degrees or 270 degrees, you would achieve a point where you will have to change the ratio. Change the ratio to what? To its complementary part. But we are dealing with 180 degrees. That means we don't have to deal with the complementary part. We can simply write minus sine 60 degrees here. The value of sine 60 degrees is going to be root 3 by 2. So minus root 3 by 2 is my answer. Right? Minus root 3 by 2 is my answer. Moving forward. Yeah. So what is the solution of the equation which lies somewhere here? Okay. So it says cos square theta plus sine square theta plus 1 is equal to 0. Now we've been given the two limits between which the solution is going to lie. Alright, there is a small glitch in the question. It says that cos square theta plus sine square theta plus 1 is equal to 0. I need to find out where the solution of this equation lies. So we have to solve it like a quadratic equation, and the glitch in this situation is that cos square theta plus sine square theta is equal to 1. So 1 plus 1 is equal to 2, which cannot be equal to 0. That will falsify the entire question. So what I would do is, there is no need of a sine square theta. This is wrong. We just need to have cos square theta plus sine theta plus 1 being equal to 0. Once I find out the value of the upcoming equation, this is an equation in two variables. Why? Because I have a cos theta and I have a sine theta. Both of them are unknown to me. I need to bring it down to a single equation, into a single variable equation. So I will convert the cos square theta into sine theta. Somehow, anyhow, I will have to do that. So using cos square theta, I know that cos square theta plus sine square theta is equal to 1. So the value of cos square theta is equal to 1 minus sine square theta. I can say that 1 minus sine square theta plus sine theta plus 1 being equal to 0. So this gives me a minus sine square theta. This gives me minus sine square theta plus sine theta plus 2 being equal to 0. I'll have to change all the signs because I don't wish to have a minus x in the equation. I can say that sine square theta minus sine theta minus 2 is equal to 0. To help all of you understand the equation better, I will consider that sine theta is equal to x. So I have x square minus x minus 2 being equal to 0. Let me split the middle term and try to find out where we are right now. I need to have a minus 1 and a plus 1. No? How would it go forward? It should be a minus 2 multiplied by a plus 1. A minus 2 multiplied by a plus 1. So x square minus 2x plus 1x minus 2 being equal to 0. If I take x common here, I would get x minus 2. And if I take a plus 1 common here, I would get x minus 2 as common. So from here, I can say that x minus 2 and x plus 1 are two factors of the equation. In x, I would replace it with sine theta. So sine theta minus 2 multiplied by sine theta plus 1 equal to 0. If both of them get multiplied and are equal to 0, I can say that sine theta is equal to either 2 or sine theta is equal to minus 1, right? Sine theta is either equal to 2 or sine theta is equal to minus 1. Sine theta cannot have a value which is greater than 1. So this doesn't stand true. Sine theta, on the other hand, can have a value which is minus 1. That is when sine theta is not 90 or the theta is not equal to 90, but some other angle which is almost equal to 90. So the same values are going to come up with different signs at 90, 270, then another odd multiples of 90, 90, not 180, 270, not 360, 540. So not 5, not even 540, 450. Yeah, 450. So at 270 degrees, I can expect that the value of sine theta is equal to -1. So if it is sitting at 270, it is sitting at 270, I need to find out where the 270 degree lies. If I convert 270 degrees into a situation which calls for pi, this is 9 2s are 18, this is 9 3s are 27, the 0 and 0 get cancelled. So I get the value 3 by 2 pi, which is nothing but 1.5 pi. Here I am sitting between 0.75 pi and 1.25 pi, but I'm looking for 1.5 pi. What are we sitting here at? We are sitting at 0.7, pi and 0.75 pi. Here we are sitting at 1.25 pi and 1.75 pi. This is where 270 degree lies. Okay, this is where 270 degree lies. That is why it was a little complicated question, but very, very interesting. Okay, let's move forward. Now I need to find out the value of theta. Here it says that sine a plus b, sine a plus b is equal to root 3 by 2. It says tan a minus b is equal to 1 by root 3. I need to find out the value of 2a plus 3b. I know that sine at 60 degrees gives me this value, and tan at 30 degrees gives me this value. So I can deduce that a plus b is equal to 60 degrees and a minus b is equal to 30 degrees. When I add all of them up, I get a 2a being equal to 90 degrees, or simply a being equal to 45 degrees, and b being equal to 15 degrees. B being equal to 15 degrees. The question says 2a plus 3b needs to be found out. The value of 2a is 90, the value of 3b is 45. So 90 plus 45 gives me 135 degrees, which is the answer that I am looking for. Okay, let's move forward. Okay, now this is a very tricky question. Okay, so again, this question has a very small glitch. It says that the value of tan this being theta is equal to 1 by root 2. So tan, in the most standard equations, we don't have tan with the value of 1 by root 2. We have tan at the value of 1 by root 3, which is at tan 30 degree being equal to 1 over root 3. So I need to find out the value of a plus b plus c. I have different values, I have different ratios, which all have a standard output. Cos theta has the value of 1 by 2 at 60 degrees. Sine theta has a value of 1 by root 2 at 45 degrees. So when I have all these standard formulas, I just need to form simple equations. So it says that tan a plus b minus c is equal to 1 over root 3. That means a plus b minus c is equal to 30 degrees by the virtue of tan 30 being equal to 1 upon root 3. A plus b minus c is equal to 30 degrees. Similarly, I can say that b plus c minus a and c plus a minus b, all of them have something or the other which is going to be very useful to us, and that is the value of cos being equal to 1 over root 2 or 1 over 2. That means we are talking about cos 60 degrees. Talking about this equation, sine has 1 upon root 2. That means we are talking about 45 degrees. So 30 degrees, 60 degrees and 45 degrees. Now if I add all of them up, a is going to get, no, we will get a plus b plus c somehow. Just let me see how. If I have 2 plus a's and 1 minus a, my output is going to be plus a. Similarly, if I have 2 plus b's and 1 minus b, my output is going to be plus b. If I have 2 plus c's and 1 minus c, I would say that I have one output being equal to plus C. So A plus B plus C, I now need to simply add all of them up. This is 105, this is 135. So A plus B plus C is going to be equal to 135 degrees. The only way or the only method which would have worked here is that cos 60 degrees is equal to half and sine 45 degrees is equal to 1 over root 2. Okay, sine 45 degrees is equal to 1 over root 2. So D is the answer that we are looking for. Moving forward, it says sine A plus cosec A is equal to 2. Now, I have this premonition that most of you would really know this equation when I say x plus 1 by x is equal to 2. In this situation, you have to always consider that x is equal to 1. That is one of the only ways to satisfy this equation, that 1 plus 1 over 1 is going to be 2. Same here. Likewise, I can say sine A plus cosec A is equal to 2, and cosec A being the opposite or the being the reciprocal of sine A, I can say that sine A plus 1 upon 1 over sine A is 2. Here I am easily able to see that sine A is definitely equal to 1. That is the only reason this equation is getting satisfied. So when sine A is equal to 1, I can say that A is definitely a 90-degree angle. Okay, A is definitely a 90-degree angle, right? So let's move to the questions quickly. It says that if sine x plus cosec x is equal to 2, then find sine raised to the power 17x plus cosec raised to the power 17x. I know that sine x is equal to 1, and likewise cosec x equal to 1. Sin x equal to 1 and cosec x equal to 1. So here sine raised to the power 17x is equal to 1 and cosec raised to the power 17x is also equal to 1, because 1 raised to the power anything would only generate 1. So sine 17x and cosec 17x both are equal to 1. So 1 plus 1 is equal to 2, and that is what we are looking for, right? Let's move ahead. Same situation has come up with a different face of itself. It says cos A plus sec A is equal to 2. I mean to say that cos A plus 1 upon cos A is also equal to 2. This is only possible in algebra if cos A itself is equal to 1. So if cos A is equal to 1, then the value of A is nothing but 0 degrees. So this is going to work out for me very well. Moving forward, it says that if cos A plus sec A is equal to 2, then find the value of sine raised to the power 6A, sine raised to the power 6 theta plus cos raised to the power 6 theta. If cos A equal to 1 and sec A is also equal to 1, 1 raised to the power 6 is also going to be 1, and here itself 1 raised to the power 6 is going to be equal to 1. So this is nothing but 1 plus 1, which is equal to 2. So my final value is 2, right? Now cos theta plus sec theta is equal to 2, then find out the value of theta. If cos theta plus sec theta is equal to 2, I need to find out the value of theta. I've already said that cos theta here is equal to 1, and this happens only when the value of theta is equal to 0 degrees. So the value of theta is 0 degrees, right? Let's move forward. Same thing, tan A plus cot A is equal to 2. The value of tan A is definitely going to be 1. That is why this equation is satisfactory. The value of tan A is equal to 1 at a special angle which is equal to 45 degrees. So I can declare that every time tan A is equal to 1, the value of A is going to be 45 degrees. Okay, let me move forward and put it into perspective with the help of a question. Tan A plus cot A is equal to 2, or tan theta plus cot theta is equal to 2. So that's why tan theta is 1, cot theta is also equal to 1. It is asking me find out the value of tan 100 theta and cot 100 theta. When I say 100 theta, I mean to say tan raised to the power 100 theta and cot raised to the power 100 theta. 1 raised to any power is only going to come out as 1. That is why it is asking me 1 raised to the power 100 plus another 1 raised to the power 100. This is only going to be 2. Got it? Let's move on. Tan theta plus cot theta is 2. Theta is in acute angle. Then find the value of 2 tan raised to the power 25, 3 and 5 something something. If tan theta and cot theta both are equal to 2, then I can say that tan theta is equal to 1 and cot theta is also equal to 1. Using the same values across the entire question, 2 into 1 plus 3 into 1 plus 5 into 1 into 1. You can put the respective powers here, 25, 20, 30 and 15. You can do that. Okay, you can put the respective powers here. In such a situation, I just need to calculate this 2 plus 3 plus 5, which is equal to 10, and this is my final answer, right? So moving forward, we are here at the concept which says that sine A plus cos B is equal to 2. In this case, we have to assume that sine A itself is equal to 1 and cos B is also equal to 1. So sine A is 1 at 90 degrees and cos B is 1 at B equal to 0 degrees. So only these two things need to be kept in mind. Moving forward, now we have this question which says that for all AI where I starts from 1 and goes till 20, lying between 0 and 90 degrees, it is given that sine A1, A2, A3 and so on till 20 terms is equal to 20. So what is the value of A1, A2 and this till 20? So if the value of sine A1 so on till sine A20 and there are all positive signs in between them, if all of this turns out to be equal to 20, there are 20 terms and the sum is also 20. This means that each term is definitely going to be 1. That means that sine A1 is equal to 1, sine A2 is equal to 1, sine A3, A4, everything is going to be equal to 1. In that case, I can say that the value of A1 or the value of A1 degrees is nothing but 90 degrees, because sine at 90 degrees is equal to 1. So A1 is equal to 90 degrees. Now the question is, what is the value of A1 plus A2 plus A3 and everything till A20? That means I have to add up 90 plus 90, because A2 is also 90, A3 is also 90 and so on till A20, which is another 90. So I am doing nothing but 90 20 times, which would give me 1800 degrees as my answer, right? Let's move forward. So this is another series which is based on cot 1, cot 2 and everything. There is one very important reminder which I wish to give you, that the value of tan 30 degrees is equal to the value of cot 60 degrees. The value of tan 0 degrees is the value of cot 90 degrees. Similarly, the value of tan 60 degrees is that of value of cot 30 degrees. So you can see that when A and B, when A plus B is equal to 90 degrees, then you would find an equal to sign in the middle. Okay, you'll find an equal to sign in the middle. Let's move to the question. Now it says that cot pi by 20, cot 3 pi by 20, 5 pi, 7 pi, 9 pi. What is the actual value of that? I know that the value of pi is equal to 80 degrees, 180 degrees. So the value of pi by 20 is going to be only 9 degrees, right? So I'll quickly write that down. I mean to say that this is cot 9 degrees multiplied by cot 27 degrees multiplied by cot 45 degrees multiplied by cot 63 degrees multiplied by cot 81 degrees. We know one thing for a fact, that cot 90 minus theta is equal to tan theta, and tan 90 minus theta is equal to cot theta. Tan 90 minus theta is equal to cot theta. So in this situation, if I have cot theta as cot 9 degrees and I put the values of 9 here in theta, I would get tan 90 minus 9 being equal to 81 degrees, right? So I can write cot 9 as equal to tan 81 degrees. So I'll use my things here and say that tan 81 degrees multiplied by doing the same thing with this cot, making it as tan 63 degrees. I would let the cot 45 remain there as it is. Why? Because cot 45 is equal to 1. So I will write its value here and I'll let cot 63 degree remain here and cot 81 degree remain here. So this 81 and this 81 gets cancelled. This gets cancelled because tan and cot are complementary in nature. So my final value of this entire situation comes out to be 1. Okay, is that fine? Let's move on. Now, talking about the same equation, we have the value of cot being added up as 77 plus 13 being equal to 90 degrees. That means these two can get cancelled, these two can get cancelled. Only cot 60 is the one which I need to account for. The value of cot 60 degrees is equal to root 3? No, 1 by root 3. So 1 by root 3 is the answer that I am looking for. See, things become so simple when you put them into the right perspective. Right? Let's move forward. Now we'll do some problems based on componendo and dividendo. We've done it already in the chapter of ratios as well as in the chapter of algebra. It says that sine theta plus cos theta whole upon sine theta minus cos theta is equal to 3 over 2. Then find the value of sine 4 theta minus cos 4 theta. So sine theta plus cos theta whole upon sine theta minus cos theta. So sine plus cos and sine minus cos. If I use componendo and dividendo, I can bring it down to sine theta upon cot theta, sine theta upon cos theta. This would then come up as 3 by 2 as 3 plus 2 is 5 and 3 minus 2 is 1. 3 plus 2 is 5 and 3 minus 2 is 1. This would give me the value of tan theta being equal to 5 or nothing but 5 over 1. If I use a triangle here, and call it theta, so tan is opposite upon adjacent. Tan is opposite upon adjacent. So 5 square is 25. This would become root 26. So opposite upon hypotenuse. Opposite upon hypotenuse. Sine 4 theta minus cos 4 theta is the value I'm looking for. Sine 4 theta minus cos 4 theta is the value I'm looking for. I can call this sine square theta whole square minus cos square theta whole square. Using a plus b, a minus b, I can say that sine square theta plus cos square theta multiplied by sine square theta minus cos square theta. Sine square theta plus cos square theta is equal to 1. That means I need to only work out with sine square theta minus cos square theta. Sine square theta is 5 square upon 26. 5 square is 25. This becomes 25 over 26. Minus cos square theta is adjacent upon hypotenuse 1 upon 26. So 24 over 26, which is also equal to 12 over 13, which is also equal to 12 over 13, right? So I hope it is very much understandable and it is very much comfortable to you, right? Let's move ahead. Same thing using componendo and dividendo. I would first do a reciprocal of this because it will be beneficial for me. I would write sine theta over cos theta. 5 plus 4 is 9. 5 minus 4 is 5 minus 4 is 1. So sine over cos is 9. That means tan theta is 9. Now it is asking me find the value of cosec square theta upon 2 minus cosec square theta. Let me quickly draw a triangle. If this is theta, this is 9 over 1. This is root 82. This is root 82. Cosec square theta, opposite of sine. Sine is 9 over root 82. What I am looking for is 82 over 81. 2 minus the same story, 82 over 81. Right. So 81 twos is 162. 162 minus 82 would give me an 80 in the situation. So this would become 82 over 81 whole divided by 80 over 81. Let me remove this calculation from your side because that wasn't really necessary, right? The 81 and the 81 get cancelled. What I'm left with is 82 over 80. This would give me a 41 over 40 as my response. So this is the final answer, right? This is the final answer. Let's move ahead. Now it says sine A into sec B is equal to 1. I would convert it to the simplest form of ratios. That means sine A over sec B. Sec B means cos B in reverse or cos B in the denominator. This is equal to 1. This means sine A. This means sine A is equal to cos B. This is only and only possible when A plus B both are equal to 90 degrees. So A plus B both are equal to, A plus B together are equal to 90 degrees, right? So this is the foundation that I'm laying down here. It says that if sec 2 theta is equal to cos theta minus 36 degrees, when 2 theta is an acute angle, find the value of theta. This means sec 2 times theta is equal to cosec theta minus 36. I'm not very fond of using sec, cosec, and cot. I'm more fond of using sine, cos, and tan because that is naturally easier. So I'll do the same thing here. I would convert the entire situation into sine, cos, and tan. This is for the ones who are a little afraid of trigonometry. I believe only knowing the formulas of sine, cos, and tan, you can sail through the entire chapter. Okay. So here I can say that sine theta minus 36 degrees is equal to cos 2 theta. I had seen the same story here. If sine A is equal to cos B, that means A plus B is equal to 90 degrees. I'll use it again here. That means 2 theta plus theta minus 36 degrees. This entire story is going to be equal to 90 degrees. Here, 3 theta minus 36 degrees is equal to 90 degrees. 36 would move here. I would say that 3 theta is equal to 90 plus 36, which is equal to 126 degrees. And the value of theta would come out to be 42 degrees. So the value of theta that I'm looking for is nothing but 42 degrees, right? It's nothing but 42 degrees. Moving forward, I have sine 58, cos 32. Both of them add up to 90 degrees. The answer is yes. That means they would get cancelled out. So this gets cancelled with this, because both of them have the same value. So it's 1 plus essentially the same thing. This is sine 55 sec 35. both of them both of them are equal as well. I'll tell you what. First, let's solve the denominator here. The denominator says that there is tan 5 and tan 85. Both of them sum up to 90. That means they must be equal. There is a tan 45 which is equal to 1 itself. So I'll write 1 over here. So the only thing which I need to worry about is sine 55 and sec 35 whole upon, no, this is not 1 plus 1 is on the outside, and this entire situation is 1 here. Okay, this entire situation is 1 here. Now I'm sitting at this sine 55 over cos 35 whole over 1. Why do I do whole over 1 all the time? There is no requirement of doing it. No, let's stop using this and let's only use this sine 55 upon cos 35. So cos 35 can be rewritten as sine 55. Why? Because both of them add up to 90. So at 90, the ratio can change. So sine 55 would get cancelled out with another sine 55, and I would be left with 1 plus 1. And the final answer is going to be 2. Good enough? Let's move on. Same scene, cos A into cosec B is equal to 1. That means cos A into 1 over sine B would be equal to 1. This means cos A would be equal to sine B. When this situation occurs, I know that A plus B is nothing but equal to 90 degrees. Right? Moving forward, when I have an equal to sign between cos and sine equal to sine, okay, this is SIGN equal to sine, and I have cos and sine on both the sides, then I know that 3 theta plus theta minus 34 degrees is going to add up to 90 degrees. I need to know the value of theta. 3 theta and this is equal to 4 theta, and minus would go there. This would create a 124, and the value of theta is going to be 31 degrees. Okay, the value of theta is going to be 31 degrees. Good enough? Let's move on. Okay, so now I have cot pi minus a 180 after school. This is going to be negative cot. I need to find out the simplified form of this entire equation. I have cot 180. I'll write it in the form of 180 or in the form of simple degrees, not in the form of radians. Cot 180 minus a multiplied by cot 90 plus a. This would change into minus tan a multiplied by cos minus a. Cos minus a is cos a because it's talking about the fourth quadrant. This would convert itself into plus cos a. Everything is in multiplication over here. Going down to this point after school 2, we're talking about tan in the third quadrant. This would give me a positive tan a multiplied by, we're talking about 90 270, tan 270 plus a after school to college. This would give me a negative tan a. This would give me a negative tan a because we are talking about the third quadrant here. We are talking about the second quadrant. We are also talking about the third quadrant or not? After school, this is 2, this is 181, this is 90 plus 3. This is not third quadrant after school to college. This is the fourth quadrant. This is the fourth quadrant. Here, pi plus a, this is the third quadrant. Cot pi minus a after school. This is my second quadrant. And cos 90 plus a, this is the third quadrant again. After school, no, it's 90 plus. No, it's the second quadrant after school. Yeah, this is the second quadrant here, and this is the fourth quadrant. What about this sine 360 minus a? Minus a after school to college. This is also going to be a negative one. So minus sine a. This is the situation that we are sitting at. Minus tan a would get cancelled. Cot 180 minus a would convert itself into minus cot a. because we are talking about the second quadrant here. Cot A multiplied by cos A whole upon, the minus would come in common here as well, tan A into sin A. The Let me break it down to the most simple form, or can we call it a quad square from here? Hmm? Let me see. Cos over sine, sine over cos, and cos over sine. This leaves me to cos cube A upon sine cube A. This leaves me for cos cube A over sine cube A. Is there a way? I don't think there's anything wrong in whatever we've done. This would definitely change. This won't change. This won't change. This won't change. So I believe cot cube A is my answer. I'll still check. So yes, the options had a glitch. Cot cube A is definitely the answer. Okay, let's move forward. Talking about tan A into tan B being equal to 1, that is only and only possible when both A plus B is equal to 90. Same goes out for cot in the other cot A. Cot A into cot B is equal to 1 when both of them are complementary to each other, or both of them complete each other by becoming a complementary angle which is equal to 90 degree together. So here we have 17 and 77, both of them would get cancelled out. 27 plus this cancelled out. Cot 45 is equal to 1. This is the only difficult part. So 1 is my final answer. Similarly, 15 plus 65, what would it make? No, 15 plus 75, it would make a 90. 65 plus 25 would make a 90. Only cot 45 is the difficult part. The value of cot 45 is 1. Right? We can find out. I'll cut the things which are cuttable. Okay, the ones which can be cut, I'll cut those things away. Moving forward, sine square A plus sine square B is equal to 1. In this situation, A and B are definitely complementary because sine 90 minus theta is equal to cos theta, and sine, if we have sine A, then sine square B is definitely going to be equal to cos square B. Sorry, sine square B is definitely going to be equal to cos square A, because cos square A plus sine square A both are equal to 1. Both together are equal to 1 when they are added. So you have to see this very well, that A plus B both add up to 90. Only then this situation is possible. Checking out the right things. In a right angle triangle ABC, its right angle at angle B, and the value of tan C is 3 by 4. Find the value of sine square A plus sine square C. Let me quickly draw a triangle. This is A, this is B, this is C. The value of tan C is 3 over 4. Using Pythagoras theorem, I can say that AC is equal to 5. So find the value of sine square A plus sine square C. So sine square A, sine square C. Sine square A is opposite upon hypotenuse. Opposite upon hypotenuse is 4 by 5. Sine square C is again opposite over hypotenuse. The hypotenuse doesn't change, the opposite side changes. 3 over 5. This is equal to 4 over 5 being 16 over 25, and another 9 over 25. Yeah, I need to add both of them up. 16 plus 9 having common basis of 25 each. This makes up 25 over 25, which is equal to 1. 25 over 25, which is equal to 1. Right? Let's move forward. Now, sine square 35 plus sine square 55. Both of them add up to 90 degrees. I've already said that. You can convert sine square 55 degrees to cos square 35 degrees. They are interchangeable at 90 degree, like 90 minus theta, they're interchangeable. So sine square 35 plus cos square 35 is definitely going to be equal to 1, right? Moving forward, we have sine square theta plus cos square theta is equal to 1. This is one of the most standard identities that we'll be reading. The question needs to have a little tweaking. This is sine square theta. The question says to evaluate 2 sine square theta whole upon 4 minus 4 sine square theta. So 2 sine theta would remain here. The 4 would come out common, and the 4, when it comes out common and also goes out of the root, would give me a 2 outside. And here I would be left with 1 minus sine square theta. So 2 over 2, 2 is now cancelled out, right? I would have sine theta whole upon in the root 1 minus sine square theta. 1 minus sine square theta is cos square theta. In the root, if I have cos square theta, the root will go away. It gives me sine theta upon cos theta. Sine theta upon cos theta is equal to tan theta, which is my final evaluation, right? Let's move forward. Now I need to find out the value of the following expression. I have 1 plus sec theta whole over sec theta multiplied by 1 minus cos theta. Okay. What do I need to do now? Let me split it up into 1 over sec theta plus 1. I'm just splitting it apart, and I would now write as 1 minus cos theta things here. 1 over sec theta is nothing but cos theta plus 1, and here I have 1 minus cos theta. I can also write it as 1 plus cos theta into 1 minus cos theta, which brings me to 1 minus cos square theta. Using the identity a plus b into a minus b is equal to a square minus b square. Yeah, this is the identity that I'm using. A plus b into a minus b is equal to a square minus b square. So 1 minus cos square theta is my answer, and 1 minus cos square theta is also called sine square theta. So this is it. Got it? Let's move on. Sec square theta minus tan square theta is equal to 1. The better way of me saying it is sec square theta is equal to 1 plus tan square theta. Sec square theta is equal to 1 plus tan square theta. This is a better way of remembering it. Nothing else. So moving forward, we now know the identity sec square theta is equal to 1 plus tan square theta. So we'll be employing it here as well. If tan theta plus sec theta equals 7. If tan theta plus sec theta equals 7, and theta being an acute angle, what is the value of 5 sine theta? Okay, so there are two variables and there is one equation. That means there is an equation missing. The equation which is missing is sec square theta minus tan square theta is equal to 1, or 1 plus tan square theta is equal to sec square theta. I'll make it sec square minus tan square theta, which can be sec plus tan multiplied by sec minus tan, that is equal to 1. I have sec plus tan equal to 7. That means sec minus tan is equal to 1 over 7. If sec minus tan is 1 over 7 and sec plus tan is 1 plus 7, then I need to achieve the value of 5 sine theta. Achieving the value of sec theta wouldn't alone help my cause. I'll still write it down. Tan theta plus sec theta is equal to 7, and sec theta minus tan theta is 1 over 7. When I add them up, I get 2 sec theta as 50 over 7, and sec theta from this equation comes out to be 25 over 7. This is not enough. Talking about if I subtract them, I get 48 over 7 as my response, and I also get 2 tan theta as my answer. So tan theta is equal to 24 over 7 in this situation. Sec theta is nothing but 1 over cos theta. That means cos theta is 7 over 25. If cos theta is 7 over 25, then and sine over cos is 24 by 7, that means, and I put the value of cos here in this equation, I will get the value of sine as 24 over 7. The cos would go to the other side and get multiplied, and this would be 7 over 25. The 7 and 7 would get cancelled. From there, I can declare that sine theta is equal to 24 over 25. And this is my final answer. Right? Let's move forward. Tan theta is equal to 4 by 5. What is the value of sec theta? 1 plus tan square theta is sec theta, is sec square theta actually. So 1 plus tan square, it is 14, no, it's 16 over 25 plus 1 being equal to sec square theta. This would become root 41 upon 5 as the value of sec theta, right? Let's move forward. Do we have an option? Yes, A is the first one. In a very similar fashion, 1 plus cot square theta is equal to cosec square theta, right? 1 plus cot square theta is cosec square theta. Yeah, so I'll be using it here. It says 1 minus cos theta whole upon 5 whole upon sine theta is equal to 1 by 5. Then find the value of 1 plus cos theta whole upon sine theta. Can we get something out of it? If I say 1 minus cos theta whole upon sine theta, I can break it down into its parts by saying 1 over sine theta minus cos theta over sine theta, right? 1 over sine theta is cosec theta minus cos over sine theta is cot theta. If this is 1 over 5, if this is 1 over 5, I need to find out the value of, let me break it down as well. This would be cosec theta plus cot theta. This would be cosec theta plus cot theta. And I already know that from this particular formula that cosec square theta minus cot square theta is equal to 1. This component, and this is a square minus b square, where I can say that cosec theta minus cot theta multiplied by cosec theta plus cot theta is equal to 1. So I have this component available with me. This is 1 over 5. And the question asks, wants the solution to this. This is the question. Let's assume this is x and this is equal to 1. So I can say, I'm assuming it to be x, okay? Need not worry a lot about it. What happened? Where did x come from? It's just a very small assumption. So x into 1 over 5, when it goes to the other side, it would become 5. So cosec theta plus cot theta is nothing but 5, or the whatever the question was, the answer is equal to 5. Good enough. Let's move ahead. So I have cosec theta is equal to 1 7 by 22. Find the value of cot square theta. We'll be using the same simple formula. Cosec square theta minus cot square theta is equal to 1. Cot square theta is something I need to find out. Cosec square theta, I'll do it quickly. This is 29 over 22. Both of them need to be squared minus cot square theta, the question which is required, and minus 1 would be done here itself. Let me do a 29 square. What is a 30 square minus 1? No, that's a difficult thing. it's better to do a 29 square. 9 nines are 81, 2 twos are 04, 2 nines are 18, 18 twos are 36. Okay, I would beat myself up because I knew it, but I still did it in the wrong way. Okay, so it's 841, and upon this and minus 1 would go here. I would get a 357 upon 484 as my answer. Okay, so 357 over 484 is the answer that I'm looking for. Now, solving quadratic equations so as to find out the value of other trigonometric ratios. Okay, solving quadratic equations in order to find out the value of other trigonometric ratios. If tan square theta plus 2 tan theta minus 63 is equal to 0, we need to find out the value of sin A and cos A and then apply them inside. So tan square A, let's assume that tan A is nothing but x for now. So x square plus 2x minus 63 is equal to 0. We could split it into 7 and 9. 7 nines are 63. So easy. One of them is bigger. The bigger one is, yeah, minus 7x minus 63 equal to 0. This would give me x plus 9 here, x into x plus 9 minus 7 into x plus 9. This is 0. So x minus 7 and x plus 9 equal to 0. Tan theta could could either be 7 or minus 9. I would take 7 as the call. If tan theta is equal to 7, if tan theta is equal to 7, this is theta, it means it is 7 over 1. This is 49, this is 1, and this is going to be root 50. This is root 50. So the question is 2 sine A. Sine is opposite upon hypotenuse. 2 sine A means 14 over root 50 plus 5 cos A adjacent upon hypotenuse, 5 over root 50. Should I bring the root 50 into consideration? I think yes. This would become 14, 5 root 2, and the 5 and 5 would get cancelled here. This would become, no, let it be a 19 root 2 directly. No, why are we messing things up? Let it be 19 upon root 50. This is my final and easy answer. Okay, perfectly fine. Let's move forward. Another one here, 7 sine square A plus 3 cos square A is equal to 4. Then find the value of cot A. Just look at the smart ways we can employ here. If I have 7 sine square A plus 3 cos square A, I can use a 3 cos square A and 3 sine square A and create a 1 out of it, create a 3 out of it. How do I do that? I split it into two portions. 4 sine square A plus 3 times sine square A plus cos square A, which is equal to 4. Sine square A plus cos square A is equal to 1. The 3 would go to the other side and it would create a 1 here. Okay, so sine square A is a 4 sine square A is a 1. So sine A is equal to 1 over 2. We need to find out the value of cot A. If the value of sine A is half, that means we are talking about sine 30 degrees here. That means value of A is 30 degrees. If A is 30 degrees, cot A at cot 30 degrees would give me root 3 as my answer. So this was something I was looking for. Easy? Yeah. So trigonometric ratio in the form of x plus 1 by x or x minus 1 by x and other options. Okay. So we have done things like this. Cot minus tan is 3 by 2. Find the value of cot plus tan. If I assume that the value of cot is nothing but x, let's assume a, because we have cot x. So cot x is equal to a. So I can say that a minus 1 over a is equal to 3 over 2. And the question asks us to give us a plus 1 by a. I will quietly square it down. A square plus 1 over a square minus 2 being equal to 9 over 4. This 2, when it goes to the other side, it becomes 17 over 4, and a square plus 1 by a square plus 1 by a square. To reach a plus 1 by a, I need to add plus 2 and plus 2 on both sides. This would give me 25 over 4, and this would give me a plus 1 over a whole square. If I now take the root of it on both sides, I would achieve a plus 1 over a being equal to 5 by 2, and this was the answer that I was looking at. The only difference is this is cot a plus 1 over, sorry, cot x plus 1 over tan x. The same thing is 5 over 2, right? The same thing is 5 over 2. Let's move on now. If sine theta minus cosec theta is equal to 6, then what is the value of sine theta plus cosec theta? No, it is minus sine theta plus cosec theta. So I can say that cosec theta minus sine theta is equal to 6. Again, we'll be employing the same thing. X minus 1 over x is equal to 6. X plus 1 over x needs to be found out. I'll square both sides, 36, and this is x square plus 1 over x square minus 2 being equal to 36. So x square plus 1 over x square is equal to this minus 2 and minus, this minus 2 would go to the other side and create a 38 here. Another plus 2 is required. So x square plus 1 over x square plus 2 is equal to 40. If I put a square root on both sides, this is essentially x plus 1 by x whole square. So x plus 1 by x whole square is equal to 40 and a root 40 here when this goes to the other side. So simply my answer is root 40. Okay, good enough. Let's move on. Simplifying using converting like sine and cos and rationalizing. Not a difficult step at all. Okay, I need to find out the value of 1 plus cos a over 1 minus cos a, and there is a root sign on the top of it. To remove the two root sign, I would need to have something which is there inside, and it will help me remove the some square thing which is inside, and it should help me remove the roof from the root. Okay, so this is 1 plus cos a whole upon 1 minus cos a. Let me multiply it with 1 plus cos a on both sides. Yeah, 1 plus cos a on both sides. Let me do that. Okay, so that will give me 1 minus cos square a using the identity of a plus b and a minus b, and 1 plus cos a whole square. The numerator part is sorted. Now the roof of the root can be removed from here, but in the denominator it can't be done yet. 1 minus cos square a should be converted to sine square a, then 1 plus cos a whole square. This root will come back. The root is now going to go away, and 1 plus cos a whole over sine a is the answer that I'm looking at. 1 upon sine a is cosec a, and cosec a and cos a upon sine a is cot a. So cosec a plus cot a is the answer that I'm looking at. Good enough. Let's move forward. The value of 1 plus sine a upon 1 plus 1 minus sine a. We'll do the same treatment as we did in the last video, like in the last question. 1 plus sine a whole upon 1 minus sine a. I'll multiply and divide with 1 plus sine a. Okay, 1 plus sine a. The upper portion becomes a square, and the lower portion, no, this is not sine square a, this is 1 plus sine a whole square, and this is 1 minus sine square a. The root remains the same. 1 plus sine a, the root will go from the top part, and 1 minus sine square a will convert itself into cos square a. 1 plus sine a, this whole square shall remain, and the root will come for the one last time. 1 plus sine a over cos a. This is my semi-final answer, and my final answer is sec a plus tan a. Okay, so the fourth option is my final answer. Good enough. Let's move on. Yeah. So yes, after solving multiple questions here, now we'll be moving to the advanced parts of trigonometry. So these are called the sum and difference formulas. I'll just read them out for you so that you can remember a few of them. So sine a plus b is sine a cos b plus cos a sine b. Sine a minus b is sine a cos b minus cos a sine b. Okay, both of them are the same. The only difference is the plus and the minus sign. Going for cos a plus b. Cos a plus b stands for cos a cos b minus sin a sin b, and cos a minus b is cos a cos b plus sin a sin b. The signs are going to reverse, as you can see here. The signs are going to reverse in the formula, and here we were following the sin a cos b, or different ratios in one term. Here we are using the same ratios in one term. Okay, cos a cos b minus sin a sin b, and cos a cos b plus sin a sin b. Then talking about tan a plus b, tan a plus b stands for tan a plus tan b whole upon 1 minus tan a tan b, and tan a minus b stands for tan a minus tan b. Tan a minus b stands for tan a minus tan b whole upon 1 plus tan a tan b. Cot a plus b stands for cot a cot b minus 1 whole upon 1 plus tan a tan b. Cot a minus b stands for cot a cot b plus 1 whole upon cot a plus b. Let me check this one. Yes, there was a small fault here. This is cot a cot b minus 1 whole upon cot a plus cot b. Here it's going to be cot b minus cot a. So you can remember this formula in such a manner that it is cot b cot a minus 1 whole upon cot b plus cot a. Okay, cot b plus cot a. This is how it usually goes. Moving forward, it's asking me the value of sine square 15 degrees. It's asking me the value of sine square 15 degrees. So 15 degrees can be formed with the help of 45 degrees minus 30 degrees, and I know both their values. So if I use this formula, if I use this formula of sine a minus b and then ultimately square it away, if I use the formula sine a minus b, sine a minus b stands for sine a cos b minus cos a sin b. Yes. So here we have a as 45 degrees and b as 30 degrees. So at a being equal to 45 degrees, I can say this is sine 45 cos 30 minus cos 45 sin 30, and I'll ultimately do a whole square to it because it's asking me the value of sine square 15 degrees. So sine 45 is 1 by root 2, cos 30 is root 3 by 2, minus cos 45 is 1 by root 2, and sin 30 is half. So I get the value as root 3 minus 1 whole upon 2 root 2. Okay, this is the answer that I'm receiving. I'll have to square it down now. After squaring it, I get the value as 3 plus 1 minus 2 root 3 whole upon 8. This would give me the answer as 4 minus 2 root 3 whole over 8, or 2 minus root 3 whole over 4. Okay. So this is the final answer that I was looking for. Moving forward, if A is 60 and B is 30, then I need to find out the value of this expression. Had I not known the formula, which we are talking about over here, I would have to use sine 60 and cos 30. But as I know the formula, I would do the most simple thing possible, which is sine A plus B. In sine A plus B, this is the formula, which is the same formula. This entire situation is equal to sine A plus B. So if A is 60 and B is 30, we are talking about sine here. So sine 60 plus 30 is sine 90, and the value of sine 90 is equal to 1. So this is the answer that I was looking for. Okay, moving on. Yeah. So we'll be now using the formula for tan A plus B. Tan A plus B stands for tan A plus tan B whole upon 1 minus tan A tan B. But if in any situation the value of A plus B is 45 or equal to 2 to 5, then I can quickly declare that tan A plus 1 multiplied by tan B plus 1 is equal to 2. So this is a deduction which I need to remember. And I need to learn it by heart. Okay, anywhere you find tan A plus 1 into tan B plus 1, you have to consider it equal to 2, provided that A plus B together are equal to 45 or 2 to 5. Okay, moving forward. If A plus B is equal to 45, we'll be using the same formula in the past. Then what is the value of 2 multiplied by 1 plus tan A multiplied by 1 plus tan B? Okay, 1 plus tan A multiplied by 1 plus tan B. This entire equation is going to be equal to 2, as we've already discussed. So 2 into 2, this is going to give me an answer of 4. Okay, 4 is going to be my answer. Moving forward, I have some more identity based questions. If I have the formula sine 2a, it calls for 2 sine a cos a, which is 2 tan a whole upon 1 plus tan square a. Okay, you need to remember this by heart. Okay, this is very important. Then about cos 2a, is cos square a minus sine square a, or 2 cos square a minus sine square a, or 1 minus 2 sine square a, or finally 1 minus tan square a whole upon 1 plus tan square a. What about tan 2a? Tan 2a stands for 2 tan a whole upon 1 minus tan square a. Remember this, there is a plus sign over here, there is a plus sign over here, and there is a minus sign over here. Okay, there is a plus sign over there and a minus sign over here. Talking about cot 2a, is cot square a minus 1 whole upon 2 cot a. And then sin 3a is equal to 3 sin a minus 4 sin cube a. And cos 3a is equal to 4 cos cube a minus 3 cos a. Okay, these are the questions, these are the identities which we'll be using in the upcoming formulas. So it says that sin theta plus cos theta is equal to root 11 by 3. Then what is the value of tan a plus cot a, or tan theta plus cot theta? Let me see what formula would work out best for me. Let me first square things on both sides. So sin theta plus cos theta is equal to root 11 by 3. It's equal to root 11 by 3. So sin square theta, I'm squaring both sides, plus cos square theta plus 2 sin theta cos theta is equal to 11 by 13, or 11 by 3, 11 by 9 actually. Yeah, 11 by 9. Now sin square a plus cos square a is equal to 1. So 1 plus 2 sin theta cos theta is equal to 11 by 9. I'll take the 1 to the other side. That will create a minus 1 there. And 11 minus 9 is 2. So 2 by 9 would come here. And 2 sin theta cos theta is something I'll get. So the value of sin theta into cos theta would be equal to 1 by 9. It will be equal to 1 by 9. Now I need to reach a situation where I can write the value of tan theta and cot theta. Tan theta plus cot theta. So we got a little stuck here when I said that sine into cos is equal to 1 upon 9. to move forward, we need to take the question forward. What do I mean when I say take the question forward? I have tan theta plus cot theta, which is something I need to find out. If I break it down, it is sin theta upon cos theta plus cos theta upon sin theta. I'll do a small cross multiplication or take the LCM here. It's not cross multiplication, it's more of the LCM. I'll take the LCM. The LCM is cos theta into sin theta, and in the numerator we'll get sin square theta plus cos square theta, which would be equal to 1 upon cos theta sin theta. We already have the value of sin theta multiplied by cos theta, which is equal to 1 by 9. We just need to put a reciprocal to it. So the value of 1 over cos theta into 1 over sin theta would be equal to 9. So that's it. That is our answer. Right? Let's move on. So there is one concept that says that if tan A plus B plus C is equal to tan 180 degrees, that means it is equal to 0. So in such a situation, we can deduce that tan A plus tan B plus tan C is equal to tan A into tan B into tan C. So you have to learn this. Okay, you have to learn this outcome. I'll be taking you to the question directly. What does the question say? It says that if tan A minus tan B minus tan C is equal to tan A into tan B into tan C, what is the value of A in terms of B and C? So for that, what would I do? I would rewrite the question here. Tan A minus tan B minus tan C is equal to tan A into tan B into tan C. I'll take this tan C from here and take it to the other side. I would be left with what I would be left with is tan A minus tan B is equal to tan A, tan B, tan C plus tan C. I'll take a tan C common here and I would be left with, this would be tan A multiplied by tan B plus 1. This entire story would be equal to tan A minus tan B. This entire situation would be equal to tan A minus tan B. So if I take it down here, I take this entire term and take it to the other side, I would be left with tan A minus tan B whole upon tan A into tan B plus 1, and this would be equal to tan C. From here, I can see that this is nothing but tan A plus B's full form. So tan A plus B is equal to tan C. If we have the same ratio on both the sides, we can say that the angles are definitely going to be equal. So the value of A plus B is equal to C for sure. And this is what I was looking for. Okay, let's move on. Now we have another half angle formulas. The half angle formulas say that if I have a sin C and a sin D, then this can be written as 2 sin C plus D by 2 cos C minus D by 2. So 2 sin C plus D by 2 cos C minus D by 2. Now you'll see this come in action because we'll be using the same formula in the next question. What does the question say? It says that sin 75 plus sin 15. It says sin 75 plus sin 15. I'll use the half angle formulas. I would say 2 sin A plus B by 2 cos A minus B by 2. Considering that A is equal to 75 and B is equal to 15, right? So this would be 2 multiplied by sin A plus B. A plus B is 90, 90 by 2 is 45. So multiplied by cos A minus B is 60, 60 by 2 is 30. So this is cos 30. Sin 45 stands for 1 over root 2 and cos 30 stands for what? Root 3 by 2? Yes. The 2 gets cancelled with the 2 and the final outcome would come as 3 by 2. Okay, the final outcome would come as 3 by 2. Let's move ahead again. Talking about this this situation, I can see that there's sine x plus y minus 2 sine x, and there is plus sine x minus y. Then I have another equation which would also turn out to be a half angle question. If you'd give me a moment, I'll definitely come back to this question. Yeah, in this question we used the plus formula. In this question, I'll come back to this one. I am now going to talk about sine c minus d formula. Sine c minus sine d is equal to 2 cos c plus d by 2 and sine c minus d by 2. I'll be applying this here. 2 cos c plus d by 2 and sine c minus d by 2. Sine c minus d by 2. Okay. So there is 2 multiplied by cos c plus d. C plus d is 90. 90 by 2 is 45. 2 cos 45 degrees multiplied by sine c minus d. C minus d 75 minus 15, which is equal to 60. 60 upon 2 is 30. So this is going to be sine 30. Cos 45 is 1 by root 2. Sine 30 is half multiplied by 2. The 2 and 2 would get cancelled. I would get my answer as 1 over root 2. Okay, I would get my answer as 1 over root 2. Moving forward, uh, find the value of sine 75 minus sine 15. So here, what formula would be used? The formula would be, we have a minus here, so this formula would come into play because this is the same formula which we just used. Okay, the cos would come first and have a plus sign, and the sign would come second with a minus sign, right? Yes, we are right from here. Then talking about the cos half angle formulas, first one in plus, cos c plus cos d, this is equal to 2 cos c plus d by 2 multiplied by cos c minus d by 2. Similarly, cos c minus cos d is equal to 2 sine c plus d by 2 and sine d minus c or c minus d by 2. So what usually happens here is that cos c and cos d, when they have a negative sign in them, then none of the upcoming answers would have a cos in them. Okay, none of the upcoming answers would have a cos in them. That is why the negative is negative. The negative sign is a negative indication to cos, that if we are sitting in a half angle formula, we should know that we wouldn't be able to represent our name again because we are cos with a negative sign. Okay, this is a way to remember this. Remember this, remember both of them and learn both of them properly. Moving forward, yeah. What is the value of cos 7a plus cos 5a divided by sine 7a minus sine 5a? Talking about cos a plus cos b. Talking about cos a plus cos b, it is equal to 2 and then the half angle formulas. 2, 7a plus 5a is 12a. 12a by 2 is 6a. This would be multiplied by cos 7a minus 5a, which is 2a, and 2a upon 2 is a. So this is what I get out of the first equation. I need to divide it now. I need to divide it by sine a minus sine b. Sine a minus sine b is 2 cos with a plus, sine with a minus. 2 cos with a plus, 2 cos 7a plus 5a is 12a. That means it's going to come as 6a. And 1 sine with a minus. Is that right? Yeah. Cos with a plus and sine with a minus with the half angle. So sine with a minus 7a minus 5a is 2a, and 2a upon 2 is a. In this equation, if I rewrite it, 2 cos 6a multiplied by cos a whole over 2 cos 6a divided by sine a, I would see that the first two terms get cancelled, and what I am left with is cos a over sine a, which is also equal to tan A. Okay, so tan A is going to be my final answer. Good enough. Let's move on. Okay, a few questions of value putting of angles. I need to find out the value of um, sine theta from here. So what thought should we apply? Hmm? What thought should we apply? I've already done the solution here for a reason, but I want you to really think what we should apply. So here we were asked to find out the value of sine theta. If we need to find out the value of sine theta, we will have to do a lot of manipulation in the equation that has been given to us. The equation says that 1 plus sine theta is equal to m cos theta. I'll let m stay here and I do 1 plus sine theta whole upon cos theta. I'll square things both sides. So m square is equal to 1 plus sine theta whole upon cos theta, and this whole right hand side is square. So 1 plus sine theta whole square, I'll let it remain here as a square, and I'll let this become cos square theta. I'll convert the cos square theta to 1 minus sine square theta, and then I'll convert the 1 minus sine square theta to 1 plus sine theta multiplied by 1 minus sine theta. So this would now convert itself into 1 plus sine theta whole square whole upon 1 plus sine theta multiplied with 1 minus sine theta. So this 1 plus sine theta whole square would have 1 upon this would get cancelled, and I would be left with 1 plus sine theta whole upon 1 minus sine theta, and this would be m square. If I use componendo and dividendo, I would be left with sine theta on the top here, and I would get m square plus 1 here whole upon m square minus 1. So this is how I achieve the value of m square plus 1 sine or sine theta, or the value of sine theta. This is how I achieve the value of sine theta. Okay, I hope you can see it really well that I did the squaring first. And then I used cos square theta as 1 minus sine square theta. Then I used the identity of 1 a square minus b square equal to a plus b, a minus b, a plus b multiplied by a minus b. Once I did that, I used componendo and dividendo at the last step. So this is how things would go about. Okay, moving forward. I need to find the value of this entire equation. So if I have sec square theta and I have 2 tan square theta plus cot square theta, I can split it down to 1 plus cot square theta plus 1 plus tan square theta. So 1 plus cot square theta plus tan square plus 1 plus tan square theta, I can change it to 1 plus cot square theta is equal to cosec square theta, and 1 plus tan square theta is equal to sec square theta. So cosec square theta plus sec square theta. Whole thing would be divided by cosec square theta plus sec square theta. Now I need to, as I can very clearly see, these two can get cancelled off. So I would take one step forward and cancel these two away. Further, I would change this 1 plus cot square theta to cosec square theta, and this sine square theta minus tan square theta, I'll do something about it by opening it. Sine square theta minus sine square theta whole upon cos square theta. So here it would be, I'll introduce, see, I can see here at the end the answer is going to be a number. So I think it will be best for me if I would break them down into the most basic forms. So sec square theta can be written as 1 over cos square theta, and cosec square theta in the denominator can be written as sine square theta in the numerator. And here I would have 1 over, I would take sine square theta common from this bracket I would take sine square theta common, and I would be left with cos square theta would go up, cos square theta minus 1. I would be left with cos square theta minus 1, right? Yeah, I would be left with cos square theta minus 1. So the sine square theta is getting cancelled out, the cos square theta is also getting cancelled out. Now, what would the cos square theta minus 1? Hmm, are we missing out some point? The sine square theta has gone up, sine square theta came out common, cos square theta minus 1 was here, cos square theta went up. Yeah, so I would be left with 1 over cos square theta minus 1. I can replace cos square theta as 1 minus sine square theta, 1 minus sine square theta minus 1. This 1 and 1 would get cancelled away. I would be left with minus cosec square theta. The minus indicates that definitely there is going to be a minus in the answer. So one of the two answers would be correct. But there is no sign of there being a 2. So I would call for this answer to be correct. Let me still find out if I can locate the hidden term which has been missing. This 1 plus cot square theta got converted to cosec square theta, and 1 plus tan square theta got converted to sec square theta. So these two equations got cancelled very easily. 1 plus cot square theta also became cosec square theta. The cosec square theta went on the reciprocal side to the numerator to convert itself to sine square theta. The sec square theta came down to convert itself to cos square theta. Right? So this portion is intact. Once this portion is intact, um, I took sine square theta common. Sine square theta common came out. It was 1 minus 1 over cos square theta. So cos square theta minus 1 whole upon cos square theta. Cos square theta minus 1 is something which I need to evaluate. Yeah. So the cos square theta minus 1, once it got evaluated, it converted itself into minus sine square theta. And minus sine square theta went up to the numerator and converted itself to minus cosec square theta. So definitely there is some term that is missing, right? There is some term that is missing. So for that we will have to check if something was actually left out, but the answer is definitely going to be minus 1 because we don't have any value of 2 anywhere. We only have the value of 1, right? Moving on. So a sine alpha or a sine a plus b cos a, we need to find out the maximum or the minimum values of it. Okay, so in the case of a sine a plus b cos a or plus minus b cos a, the minimum value is going to be root of a square plus b square, and the maximum value is going to be just the opposite of it, which is in the root a square plus b square, and whole thing would be denoted with a minus sign. Okay, the whole thing would be denoted with a minus sign. Let me do some questions of it. So I need to find out the maximum and the minimum value of 4 of 5 sine theta plus 4 cos theta, 5 sine theta plus 4 cos theta. So the 5 sine theta stands for, I need to find out the maximum and the minimum value. The minimum value is going to be root of a square plus b square, and the maximum value is going to be minus root of a square plus b square. In root of a square plus b square is going to be 5 and 4. 5 is 25 and 4 is 16. So this is going to give me root of 41 as its minimum value, and root of 41 with the minus sign as its max value. Okay, we have the minimum value as well as the maximum value, right? Let's move forward. So if at all a question comes up where we have to find out the value of sine cube theta and cos cube theta, the least value of them. So the least value would be, if you consider sine theta and cos theta multiplied with each other, and they have a common power of n, then the minimum value they can achieve is half raised to the power n, and the maximum value they can achieve is going to be infinity. So in this case, I have sine cube theta into cos cube theta. Here, the minimum value that we would achieve is going to be, we need to find out the least value. Yeah, the least value is going to be 1 raised to 1 by 2 raised to the power 3, which is nothing but 1 by 8, and this is the answer, right? 1 by 8, and this is the answer. Moving forward, x cos a minus y sin a is equal to 1, and x sin a plus y cos a is equal to 4. Then find the value of 17x square plus 17y square. Okay, I need to find out the value of 17x square and 17y square. So yes, here in this question, what we'll have to do is we'll have to square both of them, both the equations, then add all of them up, because only then we'll be able to take out x and y as common. Once we take that out, then we'll be able to reach some conclusion. So when I do x cos a minus y sin a equal to 1, and x sin a plus y cos a is equal to 4. So x cos a minus y sin a, and x sin a plus y cos a. Let me do the squaring both sides first. Then I would get x square cos square a plus y square sin square a minus 2xy cos a sin a being equal to 1. Then I'll do the same thing with the other equation. X square sin square a plus y square cos square a plus 2xy sin a cos a equal to 16. Now I think we should add all of them up, right? If we add them up, we see that these two are going to get cancelled out, and we'll have x square common, and we'll get sin square a plus cos square a, plus we'll get y square common with sin square a plus cos square a. This entire equation would be equal to 17. Sin square a plus cos square a is equal to 1. We already know that. So x square plus y square is equal to 17. So it's asking me 17x square plus 17y square. So I just need to multiply 17 on both sides, which would give me 17x square plus 17y square is equal to 289. So 289 is the answer that I was looking for. Okay, good enough. Let's move forward. So it says that if we have any equation with a sine square theta plus b cosec square theta, then the minimum value can only be found out, which is going to be equal to 2 root ab. Okay, so there are multiple cases when we have sine and cosec, when we have cos and sec, and we have tan and cot. We can only find out the minimum value in such a case, and 2 root ab is going to be the answer. Okay, 2 root ab is going to be the answer when there are opposite ratios given. These are opposite to each other. Opposite means the reciprocal of each other, complements of each other. So 2 root ab is going to be the minimum value. Moving forward, I have 8 cosec square theta plus 25 sine square theta. I need to find out the minimum value of it. I know 2 root AB is going to be my savior. So 2 multiplied by, in the root I would put 8, and I would put 25 with me. Yeah, 2 root AB. This would give me the minimum value as, this is 8, this is 200. Root 200, there isn't anything in root 2 is going to come out, and there is going to be a 10. So this would give me my answer as 20 root 2. 20 root 2 is going to be my answer. Is that good enough? Right? All right, let's move on. Then I need to find out the least value of 16 cosec square theta and 25 sine square theta. In such a situation, I would again employ the formula 2 root AB, which is going to be 2 in the root 16 multiplied by 25. 16 into 25 gives me a 400, and the root of 400 is nothing but 20. So 2 into 20, the answer is going to be 40, and this is the answer that I was looking for. And lastly, if ever we get a question where a sec square theta and b cosec square theta has been given, then we can find out the minimum value by using root a plus root b whole square. Root a plus root b whole square. Okay, so I have now 9 sec square theta plus 4 cosec square theta. I have 9 sec square theta plus 4 cosec square theta. Here root a plus root b whole square is going to be my answer. So root a means 3 and root b means 2 and whole square. So 5 square is nothing but 25, and this is the minimum value that we were talking about. Okay, now if x is a real quantity, then what is the minimum value of 25 cosec square x plus 9 sec x? We'll be using the value of 2 root ab here, 2 root ab here, 2 multiplied by, in the root we have 25 into 9. 9 would come down to 3, 25 would come down to 5, 5 3s are 15, 15 would come out, 15 multiplied by 2 or 2 multiplied by 15, we would reach 30. Okay, we would reach 30, which is the answer. Okay, which is the answer. Good enough. Let's move on. Yep. Okay, so this was actually the last question of trigonometry. We have gone through a lot of questions of trigo, and most of them have come in the exam. These are only previous year based questions, so you would be really happy to know that we completed trigo. And I would be really grateful if you could type down in the comments of what you liked, what you didn't like. If there was any question, any worry, any doubt, please drop them in the comments. Okay, thank you.